Here is part 2 of the Unit 7 Algebra 1 end of unit assessment review. For a garden, club is building a rectangular garden made from 80 feet of fencing. Determine the length, width, and area of the three different gardens that could use exactly 80 feet of fencing. So there are many different options here. Knowing that our perimeter, which is all of the outside added up together, which that would be our 80 feet of fencing, knowing that that added up has to equal 80, we can know that the width plus the length has to be half of 80, which is 40. So our length plus our width has to equal 40 feet. So right off the bat, we can do 20 and 20. We also can do 15 and 25. And we could do 10 and 30. And there are lots of options you could do. The area, we find that by doing length times width. So 20 times 20 is 400. 15 times 25 is 375 and 300. And if you need to pause this so that you can do that first, do that. Okay, given the functions k of x and g of x, find the following. Notice how these have different names, so we have to pay attention to which function it is talking about. K of x, if we're going to find 5, every time I see an x in this equation, I'm going to replace it with a 5 instead. So I'm going to have 5 minus 5, and then 5 plus 4. This will be equal to 0 times 9, which is 0. Okay, and then on the next one, k of negative 3, instead of writing x's, I'm going to write negative 3's. So I have a negative 8 times 1, which is negative 8. And then k of negative 2, instead of writing x's, I'm going to write negative 2. So I'm going to get negative 7 times 2, which equals negative 14. And then right here, notice how this changes to g of x. So I'm going to change my colors. With g of x, we have this squared, which means we have to do the order of operations before we can multiply by that 3. Lots of students will go 5 squared, 3, so they'll go 15 squared. That is not correct. You have to do the exponent first. So we're going to do 3 times 5 squared minus 2 times 5 plus 3. This will be equal to 3 times 25, because that's what 5 squared is, minus 10 plus 3. So this will be 75 minus 7, which is 68. Okay. We have to be careful with this negative, because if we do a negative 3 squared, that's going to turn to a positive 9. So then we're going to have 3 times 9 minus 10 plus 3. That'll be 27. Hold on. I went backwards. That should be a negative 3 right here. So this will be positive 6. So we'll have 27 plus 9, which equals 36. And then on the last one, we're going to replace that x with a negative 2. So we'll have 3 times 4 plus 4 plus 3 equals 12 plus 7, which is 19. So you can either do these problems this way, where you're working it all out just kind of in a row by the equation, or you could do it in the same way that these tables were done, where you split it up term by term. Okay, key features of this parabola. We're going to have a vertex right there. We're going to have x-intercepts right here. Our y-intercept is where it crosses the y-axis at that point. And then line of symmetry is going to be the line that we can fold it over so that it folds exactly in half on top of itself. And concave up, since this is making a smiley face, it is concave up. So vertex, that point is at 1, -3. Just kidding, -4. Count correctly. Okay, x-intercept is at -1, 0, and then also at 3, 0. Y-intercept is at negative, or at 0, -3. Line of symmetry, that is not a point, that's a line, so it's got to be an equation. And that equation looks like x equals 1, and this is concave up. Again, vertex, so this vertex looks like it's at 3, 1, and feel free to pause this and do this first. X-intercepts, the first one is at 2, 0, and the second one is at 4, 0. Y-intercept, that is going to be at 0, -7. Line of symmetry, that's this line where you can fold it over. Again, that looks like an equation. So that x value right there is 3. And this one is a frowning face, so it's concave down. Complete the table to plot some more points that belong to the function x. Okay, since we're missing this first value here, I don't know what it's going from, but I can keep going on the other ones. This says it goes -5, and this is -3. So these are all minusing by 2. And then I will be going -1. So then if I keep doing that second constant difference of minusing by 2, now I'm going to be adding 1, and I'm going to be adding 3, and adding 5, and adding 7. So the thing that's missing up here is I'm going to be minusing 7. So the thing that I would have to minus 7 from in order to get 9 is 16. So that's where that point is. And then it looks like that vertex happens at 4, 0, because that's where it switches. And now it should be symmetrical from there on out. And that's how we can finish up that graph of the parabola to plot some more points. And this is 1, 4, 9, and 16. Okay, hopefully that helped with preparing for the test.